Berlin, Germany. We are a subsidiary of Munich Airport, and we are about 25 people. And we are master planners of airports. We have been master planners of airports for the last 25 years. And for the last 2 to 3 years, we look very closely in what it's called AAM and UAM, which is Advanced Air Mobility and Urban Air Mobility. This whole enterprise started with a competition that we were asked by Airbus because they built an eVTOL right now, and they needed a prototypical hangar for the eVTOLs, and we won a competition. So now we are actually planning and building the first vertiport for the eVTOL next to Ingolstadt. That's the city where the car manufacturer Audi is coming from. And we're also talking to Audi. So basically, this is one of our research projects. We are involved in 2 research projects. I will talk about this in a minute. So let's have a look at this slide first. What do we do? Basically, for the vertiport planning and also the electric airport planning that I will talk about, we have a 10-point plan to approach it. To do any kind of vertiport project, every step is basically defined in those 10 steps. You start with an assumption book, which is basically a long list of assumptions that you talk to the client, which is mostly an airport or a company like Airbus or like Munich Airport. So you sit down and you do a lot of assumptions, basically saying, okay, what do we think we will need in 5 years and 10 years? What is the traffic? What is the traffic demand and forecast? So that's the first step and the second step. To do that, it always sounds kind of easy, but traffic assumption, especially for eVTOLs and electric airplanes, it's a very difficult thing because basically it hasn't started yet. And to estimate a demand of a vehicle that's not even flying yet, it's very difficult to estimate. So we have about 4 people just doing that. And we take a lot of data, that's mobile phone data, that's traffic data, that's all available data that we get, and we do assumptions. For example, we look at business jet passengers, and we say, okay, those passengers might be interesting for us for short range or middle ranges, yeah? But for the very short ranges, like city to city or inner city traffic demand is very difficult to do. So we take a lot of assumptions, we take a lot of interviews with people to find out, you know, are you willing to ride on an eVTOL? How much would you pay? What would be your destinations? So we conduct a lot of interviews, and we got a lot of data for that we have to process. So we really need data analysts to find out exactly what would be passenger numbers. And still, once we do that, there's no assurance that our assumptions are precise. So I think there's still quite some open discussion about, you know, what will be the future demand, because basically it's always very difficult to ask people about something they don't even know yet or they haven't seen flying yet. Yeah. So the third step would be the location study. And that also sounds very easy. You know, you look at an airport like Munich Airport, and there's lots of space everywhere. So, but then you start looking for where would your vertiport be best located. And then, you know, it has to be close to the terminal because you don't want people to transfer from an eVTOL to a classic airplane with a lot of distance. You don't want them to go into a taxi and go another 2 miles or so. So you need space very close to the terminal, but that's very difficult because usually those spaces, they are very valuable and they're occupied by other forms of real estate, may it be parking, may it be office space. So if you come up with, you know, planning a vertiport there, It's difficult. And we've been trying this at Munich Airport for the last 1.5 years. We looked at about 8 different locations. It ended up in a very complex matrix that's in an Excel sheet where you have about 50 questions to evaluate, and you have to give points to it. So basically, to come up with the best solution, it's a long process, and it has to be, you know, planned long ahead. And we're still not done with it because basically, you know, those decisions, they're very long lasting. So the discussion about that, it's quite long, and it's much more than we expected. So for the first 3 points, there's a lot of work and much more work that we anticipated. Number 4 would be a business design, which is basically you look at a business plan, like you do it with all the assumptions that you have done, you know, the size, the traffic, the passengers, you do a business plan. We've done that as a commercial project right now for a country in South America. So I think we're probably one of the few companies that have a full-fledged, complete business plan of a Vertiport network. And we've seen, and we learned a lot from that. So we've seen that it's basically, it is possible. It is even, you know, financially attractive. We do get some kind of IRR that's attractive to airport business. The only thing that we learned that's we really have to look closely, it's the value of the land. So if you include the value of land, of the sites, of the vertiports, and the prices, they are very high, or you have a land lease, you really have to look exactly what you're doing. So in itself, the system, it works fine. The only thing that we have to look closely is about how do we go about with the land acquisition, the land lease, or any of those locations. That's not an easy thing to solve. Then all the other things that we thought in the beginning would be complex, there were less complex. For example, infrastructure planning, also the process design, those 2 things, they were actually, you know, straightforward work to plan for a vertiport. Now I lost my screen. I don't know if you can still hear me. Can you still hear me? Hello? Hello? Hello, hello, hello?
You back. We had I think a drop-in connection on our end.
Okay.
So you were right about at point number 8, I think, in this process.
Okay, fine.
I think we've got the connectivity back. So if you want to pick it back up, that'd be great. Thank you.
Okay, wonderful. Okay. Okay, so basically, we are at number 7 or 8 in our development of vertiports at Munich Airport. The next topics coming up would be the airspace integration, and that's going to be probably the biggest obstacle that we can see because regulations are very strict, and you know, those bureaucratic bodies that we have, they're not easy to talk to, they're not easy to work with. So basically, I think, you know, in number 7, and number 8, where we, talk about the airspace integration and the certification. There's going to be some real work ahead. So we're looking forward to that, because then there's number 9, the final vertiport construction. And we are totally okay with that, because we have everything in place. And then what Munich Airport will be doing then is number 10, as a final step, will be the operational readiness and the activation of the Vertiport with our Aura team. We are very known for that, for the inauguration of airports and transfer from one airport to another. That's how our business started 20 years ago. Okay, so that is the 10-step approach. So maybe to the next slide, please. Yes, and that's showing us, showing some people of our team. In the middle, you see the Minister of Digital Affairs and Transport, Dr. Volker Wissing, and he's granting us a 4.8 million euro grant to research in this matter for vertiports and urban air mobility. It's just one research project. We have 3 of those. So basically, we are all set. We have a lot of funding. We have more funding that we can actually produce, and we have a lot to do. So basically, right now, we are full speed ahead of planning and researching of vertiports. Next slide, please. Next slide, please. Okay, next one. So my topic today is basically what is our motivation of the speech that I'm doing. So basically, you've heard in the beginning, there's AAM, there's UAM. So for the eVTOLs, if you look at vertiports alone, that's UAM, urban air mobility. Today, because you're gonna hear more presentations about UAM, I want to concentrate a bit on AAM. We're doing a lot of vertiports. We planned about 20 different vertiports so far. But the new thing, and it's basically what I think is a bit one step further than the rest, and it's a bit revolutionary, and we get a lot of response for that, and that's probably why I'm here today. It's that we've been looking into advanced air mobility. So what is the driver? And the driver for us doing that are basically 3 things. It's the challenges that it's coming ahead. The first one is that we're just out of a pandemic. And we learned a lot from the pandemic that basically, there was almost no aviation, and we saw that the terminals and the way we travel was not fit for pandemic, for this pandemic. So we had to really, we have to rethink how we are flying, and how those huge and large airports were in this case, they had a very hard time. The second point and the third point, it's basically political instability and energy and the climate crisis. That's basically one topic. So basically, the political instabilities that we have, the war in Ukraine and Europe's dependency on Russian oil and gas, it has to do, with a political instability on fossil fuels, but it's also the reason for future climate change, and we want to tackle that. So basically, all those ideas about sustainability and how we live in the future and clean tech, that's the motivation of how we want to change airports and how we want to change the way we are doing aviation. Next slide, please. So we have those challenges, and to make it short, we have basically 3 solutions to it, 3 parts of the solution. One is the introduction of new energy solution, which on the slide you can see is basically solar power and wind power. Of course, for an airport, wind power, it's a bit difficult because it's an obstacle. So, but you can have the wind power some miles away from the airport, and so it doesn't conflict with your flight routes. But it makes much more sense to have solar panels on an airport, because usually you have a lot of extra space next to the runway that's not utilized. And within the space, you can have a solar park. So basically, that's one thing we're looking at very strongly. And for the last 1.5 years, that was probably like 20% of my work was energy. How do deploy it, what kind of possibilities there are, and so on. So by being aviation experts in the future, you have to be also partly an energy expert to really know and understand what you're doing. Second one is new aviation technology. So here you see an eVTOL, that's the new Airbus Next Gen, but that's basically just a symbol. We're going to look into that in a minute. And the third one is new airport concepts. And you see this diagram, it's a decentralized diagram. So we are looking at different forms of how aviation can be done in the future. And it's probably the solution that we see is in decentralized aviation. Next slide, please. Okay, look at the number one that I just talked about. That's the energy solution. So how does energy look at airports in Europe? So basically, we have Airport Vienna. That's one of our clients. They have a 24 megawatt solar farm right next to the airport. And on a sunny day, the whole airport, which is quite a big airport, I think it's got like 20 million passengers, I'm not quite sure. It's totally running on solar power on a sunny day. So basically, they're very far ahead, and we're looking at the same solution for smaller airports. I have this benchmark. As master planners, we love benchmarks. So we have like 1 megawatt power. It's about 1 gigawatt hours a year. And that corresponds to a land use of about 1 hectare of land area. And the costs are roughly 1 million euros. So basically, you know, this can be adjusted anytime, and probably now it's even a bit cheaper. But as master planners, when you're at your client side, you have to know and you have to give answers right away. So when you see spaces, an area of land, you can very quickly say, okay, in this space, you can build a solar park of this size. It costs you that much, and it will give you that much energy, which will give, you know, as a conclusion, a lot of starts and landing for electric airplanes or eVTOLs. Next slide, please. Yes, that's one of the many regional airports around Berlin, the capital of Germany. And basically, we were extremely surprised when we looked and researched how many regional airports around Berlin exists. And we talk about regional airports that have a runway of about 1,000 meters and have a lot of space around it. So we have 61 regional airports that fulfill that. Why do we have that many? Lots of them. There's only 3 or 4 that are really in use. All the others are ex-military, ex-Russian, ex-army, ex-East German army, ex-West German army. So basically, you're left with a lot of infrastructure that's underutilized. And the same situation you have in France and also in the USA. There's a lot of underutilized regional airports. So to be sustainable for us, number one is, you know, use what is already there. And funny enough, like 20 years ago, when those airports were not used anymore and abandoned, people moved in and built solar parks. So we are not even left with more than 60 regional airports around Berlin. We also left with about 20 or 25 that even already have a solar park next to it. So if you look at this one, Eberswalde Fino, you have a 155 megawatt solar park at this airport. You have a relatively short runway, but that's it. That's all you need. So basically, there's no it's not utilized anymore for as an airport, as a military airport that it once was, but it could very easily and very cheaply be converted into an electric airport. So we looked at those and we thought, you know, why not? Why not give it a shot and look at it? Because about 50% of the infrastructure that we need is already there. So that's what we're looking at. Next slide, please.
Olaf, I'm trying to, as a moderator, keep us on time. So
Okay.
wrap up in
How
the
much,
next
how
5
much time
minutes.
left?
If you could wrap up in about 5 minutes, we'll pass it over, and that will give us some time for Q&A at the end.
Okay, then let's move on a few slides because I probably talked too long and too much. I'm sorry. Okay, next slide, please. Okay. So we're looking at eVTOLs that have a short range of less than 100 kilometers. And next slide, please. And also we look at small electric airplanes that have a medium range from 400 kilometers right now up to 1,000 kilometers. So that's the future in about 5 years of electric airplanes and eVTOLs that we are looking at. Next slide, please. So we looked at the new concept of how this can be achieved, what can we do? And we have to the left the old hub and spoke system like it exists right now. And we have to the right what we suggest, which is a point-to-point decentralized network of regional or, regional airports mostly. Next slide, please. So this is basically the most important slide. If you only remember this slide from my presentation, I'm totally happy because that says it all. So to the left, that's Berlin as a shape, and then you have the big airport. And the idea right now is, with eVTOLs, basically having the function as an airport feeder only. And we think the other way around. So our concept is the one to the right, where you have multiple vertiports within a big city, and then you move one step, the first step in blue, P1, with an eVTOL to a regional airport that's outside your city boundaries. So you can look at any large city and you can do that. So you have a relatively short distance with an eVTOL, and then you change quickly, and you then have a second flight with an electric airplane that can go up to 1,000 kilometers. With this concept, you can easily reach, many destinations with, we calculated up to 1,000 kilometers of range. It's about 50% of all flights that we have right now in Europe. Next slide, please. So how would this, that's the range. So from Berlin to Venice, from Berlin to, London, it would all be possible on electric flight. Next one, please. And how would this airport look like? And now we come to the final. So we did a schematic sketch. We have a runway, usually about 1,000, 1,200 meters long. That would, be okay for almost any electric airplane, and also combination of conventional airplanes. If they have to land and start, this would be also possible to run this little airport, on electric, but also on classic fuel for a while if you want to. So next to the runway, you have a solar park. You have about 6 B-type electric planes, and you have about 12 eVTOL vehicles to feed this terminal. So next slide, please. Next, please. So we did this, and I've got about 5 slides to go. So basically, what we did is that we designed this airport in a way that you can independently expand every element. If you want a bigger solar park, a bigger runway, a bigger terminal, a bigger utility building, or more stands, it's all possible without conflict of any other function. So we took a long time to come up with that. Next slide, please. And that's how it looks. So you have a big solar park. You have a runway of about 1,000 meters. And on the bottom, you see you have a terminal building that combines a vertiport and an airport. That's the first one that has ever been designed this way worldwide. So we're quite proud of it. And to the right, you have either an airport city or you have a cargo city, basically, because we believe you can have passengers during the day and cargo during the night, and you get a much better business plan with that. Next slide, please. So that's pretty much how it could look. That's basically, quite a lot. So you can, but you can start small. You can start with, 1/2 of the terminal building for the passengers. You can also start with only very little for the cargo and just go piece by piece and let it grow. So that's what we have. So we have about 12 eVTOLs that feed the passengers from the big city into this airport. And we have 6 positions of electric planes that can be 9-seater, that can be 25-seaters, that can be up to 40. So that's how we want to do that. And that can host up to, anything between 300,000 and 1 million passengers, even there. So last slides, there are a few impressions from the inside. Maybe next slide. We
I
can
think
skip.
last slide, we'll go ahead and advance, and then we'll wrap it up and pass it over to Rex.
Okay. So next one, please. That's just the diagrams. Maybe if one is interested, you can get the presentation later and look at it. Next one, please. Next one. Next one, I just want to show this interiors. Yeah. And we want to build this as a wooden construction. It's all on one level. There's no escalators, no elevators, no, there's no pushback. It's a very simple building with inner yards that are green and are open spaces and have natural ventilation. Next slide, please. And that's basically my last slide. So basically, that's how we imagine this terminal to be an open space and looks more like an internet cafe than it looks like a conventional terminal. So that's pretty much for what I have to say. I hope I'm not that much over time. I'm sorry to talk so much. I hope you enjoyed it. And if there's any questions, please ask.
Thank you so much, Olaf. That was a great presentation. Lots of great content there and great visuals. We will keep you on the line if you don't mind for Q&A at the end. But in the meantime, let's invite Rex Alexander. He's the president. He's also an infrastructure advisor to in general. Emphasizing some of the conversations we'll have today around international standardization, what we're doing here in the United States. So Rex, please come on up and take the main podium.
Well, thank you very, very much for being here. It's a great honor to speak to you, and thank you for the opportunity to share my knowledge with you. So what I'm going to do today is give you a very, very high level brief overview. I do teach this for the Transportation Safety Institute in Oklahoma City course 8 hours a day. And that doesn't even get into code regulations, which is another 3-day course. I'm going to do that in 20 minutes. All right, first slide. So when we look at what the FAA is doing right now, these are quotes from the Federal Aviation Administration. Said limited data. That's one of the things they pointed to on the performance capability of eVTOL aircraft. They're working through that. With limited data, it's very hard to come up with a performance called Vertiport Incorporated. We're on brief as well as the advisory circular that if it's wrong, you can blame me. In this space, we look at the guidance is evolving. That's one of the things the FAA says. We're going to be very prescriptive. We're going to be very conservative in the beginning, and we're expecting that information provided from data to guide us in the constraints in the future. To start out with, we're going to be very prescriptive. Next slide, please. So the FAA is currently in the research. We're expecting the advisory circular, and that's what the FAA chose to call an airport advisory circular. They have a heliport advisory circular. They even have a balloon port advisory circular. This Vertiport advisory circular is expected to probably be published in 2025. So the engineering brief 105 was published, and it's in service until that AC is published. Once the AC is published, the engineering brief will cease to be canceled. Now, in the we have 105. That's the guidance we've been giving. Next slide. So this is the engineering brief. It was published September 21st. It was the second standard for Vertiports. The first standard was published in August by ASTM International. This is directly from the FAA put in the engineering brief. Again, interim guidance. It's performance criteria, the design characteristic of the reference aircraft. So they had 9 participating aircraft from OEMs, this engineering brief. So out of 9, the Vertical Flight Society is tracking somewhere in the neighborhood of 800 different eVTOL concepts on the market. So only 9 out of 800. That percentage is not very high. So in the future, we're hoping to see more data to guide us. Aircraft is also considered VMC, vertical. Not instrument flight rules, not unpiloted or the 4 words up here that I highlighted are the most important ones out of this slide is public versus private. And then what's the difference between a vertiport and a vertiport? The existing heliports, helicopter and airplane landing facilities and establish of new sites. So there's several different layers here that we have to unpeel. We have the design of new, then we have the retrofit of old, and then we have the combination of the two. So there's different guidances in the engineering brief that kind of speaks to that, but it's not completely clear. Some of that gray area, the in-betweens, when you're doing something together. Now, the FAA has said that they're probably going to release an update to the engineering brief, maybe yet this year, but before the AC is published, because there's some things that they didn't speak to that they want to. Next slide, please. Now, if we go into the public-private, this is one of the challenges in the United States. In the United States, we only have 2 categories for use case, public or private. And I'm not sure why I have a double image there, but out of the Code of Federal Regulation, that's a higher bar when it comes to risk evaluation in 2 ways. One, the FAA has no authority over private use. So no matter what you do, the FAA has no authority to come in and control that. The state in the United States could, or the local municipality could. However, one of the caveats to that is if I have a private use facility, I can spell out exactly how I want operations, have a letter of agreement with all the people that go in and out of there. I can require you as an operator to meet a certain training requirement, also to have a certain level of insurance. Public use, and the challenge we run into public use is that it means it's available to everybody in the general public. So I, as a 60-hour private pilot, am allowed, and actually the FAA says required to be able to land there. Now we deal with public use with general aviation at somewhere like LAX because we have a separate segregated area. We have the private general aviation ramp separate from the ramp for commercial aviation. When we look at vertiports and heliports, we do not have the real estate to segregate of a couple hundred operations an hour to a day. Do you really want somebody that has 60 hours in their private aircraft landing and taking off in vicinity of a high throughput operation? So that's one of the challenges we're dealing with in the standards. Is we're also looking at another case study. A lot of states use the term commercial operations. The federal government does not federal grant money. Public use facility, if you do acquire it, you have to be. What's the difference between a vertiport and a vertistop? Easiest way to say it, they're exactly the same. No no several companies out there that are working on a hybrid system, but we're also looking at the hydrogen system as well, hydrogen fuel cells, and there's some other things out there that we're looking at in the novel concepts as well. Instrument flight rules, that's again, we're talking VMC, visual meteorological conditions, visual flight rules only as of right now, and the use of multiple final approach and takeoffs or FADOs, multiple areas for landing. Next slide, please. Again, the reference aircraft represents a VTOL aircraft that integrates certain performance and design characteristics of 9 aircraft. Again, there are 800 out there, and there's probably more than that that are in testing. Next slide, please. Reference aircraft, current limited demonstrated performance data, performance-based aircraft on Vertiport design. We get into the categories, and this is one of those things that is interesting because they actually quantified categories. Currently today, there's not a different category of heliport. There's a heliport is a heliport is a heliport. When we look at vertiports, what is a class 1, class 2, class 3? That will probably be based on performance available criteria of each individual aircraft. Now, back in the early 80s, they did research and testing for heliports with helicopters, and they found that there was a need for classification for performance levels, but they never actually used that. They never indoctrinated that into the helicopter industry. So there is really good research that points to the fact that performance for infrastructure is critical. It's just that they had received so much pushback from the industry on that they never implemented it. Next slide, please. So these are just some of the things on the reference aircraft. You'll notice that electric battery driven using distributed electric propulsion is the criteria. 12,500 pounds, maximum length and width 50 feet. So anything greater than this would not fall into this category of the reference aircraft. It would be something other than. Next slide. Land-based, so we're not looking at anything that's off water. Water-based, amphibious, or float operations in this current engineering brief. VFR pilot on board. Next slide. If you don't know what hover out of ground effect means, it's performance classification for helicopters. It's in the certification requirements under Part 27 and Part 29. When an aircraft, helicopter, or an eVTOL is in close proximity to the ground, the airflow is actually getting resistance. And as that resistance pushes back, it requires less performance from the aircraft to do that hover. Once the aircraft leaves that area, it gets into what we call out of ground effect. Rule of thumb for helicopters, 1.5 times rotor diameter. You're into a higher performance requiring area for flight. So that's one of the things we pointed to in the eVTOL is if you're landing with a out of ground effect, normal operations, it must be able to have that performance level. It's quantified as being able to take off vertically and land vertically. And then the downwash, outwash is something that we're looking to measure because we're not sure what that is yet. So we have the downwash from the aircraft itself. What's that velocity? What's the impact on its environment? Also, there's something else I don't have up here in the reference to the FAA, but there's also the wake turbulence that the aircraft produces. We know that there's wake turbulence produced by heavy jets that we want to avoid, but there's also a wake turbulence created by helicopters that you don't want to fly through. Now, the rule of thumb that they came up with in the FAA is about a 60-second separation for light helicopters and about a 90-second separation for heavy helicopters. Again, using that 12,500. We don't know what that is yet for eVTOL. We haven't studied that. Next slide. Other than if you have an aircraft that doesn't meet that criteria, then you're going to have to sit down with the authority having jurisdiction for the infrastructure, which is the airport district office for your region, and come up with a plan forward. So if you have something that doesn't fit that, then it's going to take a little bit longer and a little bit more effort. Next slide. Didn't talk about taxi and parking in this first engineering brief. That's something that they want to attack. And that's important because when you look at high throughput, you're going to need parking areas. And how do you move the aircraft across the ground is a really, really important piece of the puzzle. Are you going to hover taxi? Hover taxi requires a lot of energy. You're going to burn a lot of energy moving the aircraft. So you're probably going to want a ground taxi. Even ground taxi produces outwash because of using the energy, and you're going to limit your energy. So then we get into ground handling. We actually use a tug or a dolly to do that. What's that look like? And we haven't done that research yet, because each one of those movements has a significant impact on your footprint from a geometrical perspective, because hover taxi requires more room versus ground taxi. And then you get into the ground handling requires less room than all three. So that's going to increase or decrease your footprint. Next slide. What's the difference between a heliport and a vertiport? So in the FAA, they look at, if you're going to have a heliport converted to a vertiport, it needs to meet the transport heliport category. Now in the advisory circular that was in place, 2C for heliports, now 2 Delta, I can tell you that nowhere in the United States is there a heliport that has ever been designed to transport category standards. None exist. Now, that being said, most of the heliports in existence aren't really good heliports, and they're very constrained by their surroundings. To convert a heliport to a vertiport would be, I won't say impossible, but very hard in many cases, because you don't have the real estate necessary to support your business model. Most of the 99% of all the heliports in the United States are private use. 60% of all those are medical for hospitals. The private heliports that we use today also have to go through a conditional use permitting process for the local land use municipalities. That's a challenge because most of those have caveats to their requirements. When I sit down with a client and we put in a heliport, we have to agree to certain restrictions. Daytime operations only. Hey, you can only land and take off at this location 4 times a day. Oh, by the way, you can't do commercial operations, no refueling here. And it goes on and on. So when you look at converting a heliport today into a vertiport tomorrow, it's a very steep hill to climb. Airports make a much better case, especially small regional or small city airports that are public use, because you get better airspace, you got more activity that goes on there any given day, and you have better access to electricity. The average heliport doesn't have electricity. If you do have electricity, it's probably 110 volts to run the lights around the pad. To get a 350 kilowatt charger in there is going to be a challenge. Next slide, please. There's a ratio that we use in a helicopter design for a heliport. The main rotor versus overall length is a very consistent ratio. That same ratio does not exist in the vertiport world or in the eVTOL world. Next slide. Performance minimums, effective translational lift, and hover out of ground effect are the 2 primaries they point to. Next slide. This is a new acronym, controlling dimension. It's basically equates to what we refer to in KAEA as D, or overall length. So this is now the new D. We use rotor diameter a lot of times in the past, but controlling dimension. Next slide. Design and geometry. This is straight out of the book. This is a size that we're looking at today. Next slide. This is the original identification from the 1990s for heliports. There's testing going on right now at the FAA Tech Center to identify if this is the right symbol for vertiports. Next slide. We talk about conversion, redesigning. That's a criteria in the engineering brief that speaks to that. Again, I said it's challenging to do that. Next slide. Charging electricity. One of the groups that wrote the section in the FAA engineering brief that I would pay very close attention to, if you're not familiar with it, it's called NREL, National Renewable Energy Laboratories. They're actually a government agency out of Denver, and they do a lot of work in the renewable energy world and have written a lot of some of the better white papers in this space for charging. Next slide. One of the things at airports, or even at airports and heliports, is what's the separation between the aircraft. This is where we get into wake turbulence separation for aircraft between lights and heavies. We don't know exactly yet what the eVTOLs will produce for wake turbulence. Next slide. Benefits existing airports, existing clear airspace, access to electrical grid, room to grow and expand, capacity for high throughput, mass transit access points. Your average heliport doesn't have that. Next slide. Downwash, outwash, we're doing research on that right now, working with Vertiport. We're actually getting ready to kick that off here pretty soon. Next slide. Real quick, other standards. Next slide. ASTM International has Vertiport standard, was published August 2022. Next slide. National Fire Protection Association. I'm the chair of NFPA 418, which is a heliport, now heliport Vertiport standard. We just finished our last go around. Expect that to be published as early as December 2023, but as late as June 2024. That'll give fire standards for municipalities. Next slide. International Code Council. Haven't seen anything from this group yet. They're the ones that design building code and fire code. We need to engage this group because the municipalities lean on this for heliports. We'll lean on it for vertiports. Next slide. New group out there that I worked with for the last couple of years, designing a standard for illumination, IES. This is not the landing area. This is the surrounding area, the parking area. This is the refueling area. This is the loading area for cargo and things like that. But the IES, it's an ANSI standard. Next slide. International Civil Aviation Organization, KAEA, hasn't done anything in this space yet. Their first meeting is not until September 2024. Next slide. Municipalities and local governments all over the board. Some are embracing it, some are involved, some are engaged, some have not learned how to spell advanced air mobility or AAM. So everything in between. Lots of education to be done there. I won't go through that. Next slide. Where to go for information? Vertical Flight Society. I've got some magazines, just clips out of this. There's actually an article in here that I wrote for Vertical Flight Society on infrastructure standards that you'll probably find interesting. I got some there and there's some out front. Website, vtol.org. We just did stand up a new page specifically for infrastructure of eVTOL. We have two events coming up, the annual electric aircraft symposium, which will be in Oshkosh. That'll be our 17th annual symposium. And then I am in charge of our 7th infrastructure workshop. We'll be doing it out by the Aviation Tech Center in Atlantic City in September. So those events are on our website. If you have any questions on that, please don't hesitate. That was quick, but that wraps up my piece.
Thank you, Reps. Really informative presentation. So we heard a lot today from our first two speakers about, I think, need for data in order to inform standards, some harmonization of those standards internationally. We heard a little bit about opportunities and challenges of existing and new infrastructure, the sort of complex governance landscape, and the need for that methodical planning process to get AAM off the ground. So I think we have a couple of minutes for questions. If there's any from the audience, we have someone circulating with a microphone, and please feel free to raise your hand and we'll come around and tap our speakers for you.
Thank you so much. Great presentation, Rex and Olaf. My quick question is, out of your experience seeing what's happening around the world with implementation or with studies and with all the assessments of the capabilities of a vertiport, are there good benchmarks besides Germany that we saw today, maybe Korea with their vertiport technology, Long Beach, any cities that you think, oh, this, municipality is coming forward with some good regulation for the development of this industry? Thank you.
As far as regulations go, I haven't seen any for vertiports. I would say there's some really good regulations from an ordinance standpoint at the local municipality that are for heliports that would probably be a great starting point for a template for vertiports, because there's certain things you want to look at for municipality is what's the setback to your neighbor? What's that distance? What's the volume of operations? What's the noise you're allowed to produce? What is the noise criteria for your local area? The FAA is not going to quantify that for you. That has to be done at the local municipality. There are some really great ordinances out there. They're all across the country. There are also some really bad ones. So be careful with what you copy.
Thank you.
Hi, thank you to both presenters. I wanted you to expand a little bit when you were differentiating public and private, and you mentioned commercial operations that as a nuance that the FAA is looking at. So if you could say a little bit more on that, and then vertiport, vertistop, no maintenance, what what does that mean at a vertistop? Not even light maintenance that maybe a pilot or crew could do versus, you know, we talk about light maintenance versus heavy maintenance. So just get your thoughts on both these things.
Okay. So I'll go with the last one first. So when we look at the maintenance, and what we like to say is scheduled maintenance, because that was one of the things we said, if your aircraft breaks on the pad, you're going to want to fix it. Now, having had a helicopter blow an engine in a waste treatment plant and change an engine for 3 days, yeah, it may be a significant issue. You may have to do a lot of maintenance. So what we looked at is you should never schedule maintenance to be done at a vertistop. If you're going to do that, hey, great, call it a vertiport. I mean, that's as simple as that. It gets down to the fact that there was a lawsuit in New Orleans because a hospital called it a helistop, and then they started doing maintenance and storing their aircraft there, and it was certified by the local municipality as a helistop, not a heliport. So it got real ugly real quick. So I think, there's, things you have to call it. Your second question again?
That was the second. The first one was commercial operation,
Okay,
public
there you
private.
So when we get into that classification, there's use case and ownership. So public private is the only thing we have on the federal registry. If you look at a lot of states, they have additional, they have public private, but they also have personal. So it's only you, your family, and your aircraft, period. All the helicopter landing areas in the United States that are hospitals are all private. There's no public use facility that's a hospital heliport. That means that the FAA has no authority over them also. However, all of them are doing commercial operations. So when you look at states, some states actually have commercial as an quantifier. What that allows them to do as a state is to hold that hospital to a higher level of standards, because the person in the back of an EMS helicopter has no choice of the matter of where they're flying, who's flying, and when they're flying, and what aircraft they're flying. Unlike you, when you get in American Airlines, you get to choose what aircraft, when, what aircraft, where you're taking off, where you're landing. You have all these choices. They are actually required under Part 139 to be certified. And that's one of the things that we're looking at here. One document that we looked at really closely that's really interesting is one I would point you to is you talk about operations under Part 91, Part 135, and Part 121. There's a defunct canceled document out there called Part 127 that's extremely interesting to read. That was commercial transport helicopter operations. And it's amazing how much that actually applies to eVTOL, advanced air mobility operations. It's between 135 and 121.
So you see the states leading in that regulation, in that classification, or the FAA delegating, or are they expecting states to come forward with proposals?
I think the FAA needs to step up and lead, but they need to bring the states with them. And there needs to be a conversation at the table. The group that we work with through the Vertical Flight Society is called NASAO, National Association of State Aviation Officers. Smallest group in Washington, D.C., but they have some of the most power because most AIP funding goes through NASAO. I would love to see more collaboration between FAA, NASAO, VFS, HAI, and all the alphabet groups, because I think that's the only way we're going to get there.
Thank you.
So at this point, I know we do have people on the line. So we'll do one more quick question, and I think we'll transition to the next group.
Thank you for your presentation. What is the realistic timeline before we get to see the wide use of personal use as well as the commercial use?
I think on the personal use, you might see that sooner. There are aircraft out there that individuals can purchase. They would be under a different section because they would be under ultralight and or experimental. So in that space, that's an avenue for them. Now, if you're going to transport passengers or cargo for compensation, i.e. commercial, well, now you have to be certified. So that's, I think, the longer pole in the tent is waiting for the certification. You got to certify the aircraft, then you actually have to produce the aircraft. Then you also have to get all the pilots trained, and you have to have a training program, a maintenance program. That's going to take time. So I'm looking at personal operations. There's going to be somebody out there doing this today. They may not be landing and taking off at vertiports. They're probably landing and taking off from their backyard. I would say commercial operations, an actual commercial model, I would I would point to 2025 as probably the first commercial model. They may not have a certified aircraft. They may actually use it as a demonstrator, as an experimental model. There's that option too. So I could be proven wrong. I've been proven wrong before.
Thank you.
Maybe I can add to that.
Great.
This
Well,
is
thanks
Olaf.
everyone for those questions. Thank you, Rex, and thank you, Olaf, for your presentations today. Extremely informative. So that was a great, I think, level set for all of us on Vertiports, what's going on from a regulatory perspective from a couple of different places globally here in Europe. We're going to transition to our second session, which is really going to focus on startups, Vertiports in the context of airports, and Vertiport planning moreover. We've got some great speakers, and I'm pleased to introduce the first one, Sunay Min, who's the president of Enridge. Enridge provides infrastructure for, and they build EV charging stations, install charging systems, and ensure operational charging, or ensure operations are running smoothly, we'll say, on the energy side. So thank you so much, and I'll pass it over now.
Hello, my name is Sunay Min. I'm the president of Enridge. It is an honor to talk about Enridge's charging hub as a first stop in the KAEA Symposium. Enridge was founded in 2014 with the mission to build a sustainable and smart world. And in 2018, we expanded our solution to EV charging station project to reduce carbon footprint from the transportation. We developed our EV charging specialized brand, Fleetway, to provide a reliable and convenient charging experience to our clients. Now, we are actively building publicly available EV charging stations and multifamily housing EV charging stations in the United States. Enridge's vision is to build and operating multimodal charging hub stations, which extends to air mobility charging. And we are preparing ourselves to build Enridge's charging hub as a first stop near in the future. Rex introduced the charging hub and the charging port, EV port and EV stop, the differentiation, but I combined the first stop with a charging station function in the charging stop. So understand this as a charging first stop with a charging function. Next slide, please. For the past decades, we've seen nearly every mode of transportation go electric or zero emission. It started with electric bike, electric scooters, and go to light duty, medium duty, and heavy duty vehicles. It's mostly because of the environmental concern, climate change. US government, and especially the state of California, strongly drive toward net zero emission. For example, in California, from 2035, all new car sales should be zero emission vehicles. And at the Port of Long Beach, as the global industry leader of the port industry, set a goal of net zero emission cargo handling equipment by 2030 and a zero emission drayage truck fleet by 2035. And the aviation is the next. So we need to plan to appropriate the charging infrastructure at individual airports and the networks of the airports to expand the range of flight service before the electric aviation industry takes off. Next. On November 9, 2021, the Federal Aviation Administration published the United States Aviation Climate Action Plan, which describes government's approach toward achieving net zero emissions by 2050. Electric aviation-related plans among several actions are development of new, more efficient aircraft and engine technologies, and the production of sustainable aviation fuels using solar farms and hydrogen power plants, wind turbines, and utilization of energy storage systems. Electrification and hydrogen as solutions for short-haul aviation. This section includes electric charging stations and hydrogen fueling stations. And international initiatives such as the airplane CO2 standards and the carbon offsetting and reduction scheme for international aviation. EV charging and hydrogen refueling charging station also reduce CO2 emissions. Support for research into climate action. So therefore, EV charging, electric vertiports with a charging station may be part of the US Aviation Climate Action Plan. Next slide. Biden administration's bipartisan infrastructure law is the largest federal investment in the public transportation in the nation's history. Among the bipartisan infrastructure law, $15 billion of the funding is allocated in the airport infrastructure for the next 5 years. It will modernize infrastructure, increase equity in transportation, help fight climate change, strengthen the supply chain, and create jobs. As another funding, FAA administers Airport Improvement Program, which provides grants to public agencies and private entities and owners for the planning and development of public use of airports. But AIP fund is drawn from the Airport and Airway Trust Fund, and there are some eligibility requirements for the airports. So for the funding, for large and medium primary airports can receive the grants at up to 75% of the eligible cost, and small and general aviation airport can get the grant at up to 95% of the eligible cost. The funding size is $3.18 billion annually to more than 3,300 eligible airports. The eligible projects should be enhancing airport security and safety, capacity, and environmental concerns. It should be renewable and an energy efficient and a CO2 emission project, CO2 emission reduction project. So when we electrify air mobility, the next slide. When we electrify air mobility, it will bring about revolutionary transformation in the airport. Fueling system should be changed from gasoline fueling system to electric charging system. And aircraft, gasoline fuel generates the greatest amount of CO2 emission, but the electric is carbon-free fuel. Therefore, it brings a huge environmental impact. Next. When we electrify air mobility, charging infrastructure needs high power solutions. So high power charging system will enable quicker charging, reduce turnaround times, and minimize ground time between flights, extend the flight range, increase flight frequency, and improve overall operational efficiency. So aviation charging has a specific requirement. For the ground vehicles, when you drive electric vehicles, you can drive up to the charger as close as possible. So you can start charging, but for the aircraft, you cannot drive up to the charging station. Aircraft will land on the certain spot, and the charger should reach out to the charger with moving wheel or extended cord. So movable chargers and extended cables should be introduced to the aircraft charging. But high power charging cables are too heavy to handle. So the thickness and the weight is the hurdle, obstacle to be taken care of. When the ground vehicle drive up to the charging stations, will stop or bollards will block the vehicles in front of the charging station for the safety measure. But in the aviation charging, because of the aircraft's wingspan and the rotor diameter, low height charging station would be better to prevent any possible incident. So lower height chargers have a spatial advantage and reduce vertiport complexity. Next. So aviation charging requires special solution in the charger characteristics. So for up to 175 kilowatt hour battery size vehicles, 350 kilowatt charging station will be sufficient for 30-minute charging, fast charging. But for above 175 kilowatt hour battery size, then super fast charging station is required for 30-minute charging. So if you want overnight charging, it doesn't matter. If you have just a lower charging station, you can charge it over the night and you can use it at aircraft. But if you want a fast charging system, fast charge, then you have to get a super high super charging station up to 1 megawatt or even 2 megawatt system. Charging stations are needed. As the charging power goes up, the charging cable should follow the charging power. Then the high power charging cable will be thicker and heavier, and it's a problem. Also, the charging cable's length should be longer than the ground level transportation charging cable. So, but however, safety must be the first priority measure in the aviation charging, because this fast charging station puts battery under the management of external charger. Exceeding the maximum charging voltage or current could damage the aircraft battery and then create a safety risk. So some amount of FAA and EASA oversight is warranted. There are several standardized connectors in the market for up to 350 kilowatt charging station based on the region and then car model and the charging power. So on the left side, the level 2 charger is good for every electric vehicle, including hybrid. But CCS 1 and 2 DC fast charging can cover up to 350 kilowatts. CCS 1 is used in North America, and then CCS 2 is mostly used in Europe area region. And the Tesla charging they have a specific charging cable for supercharging station. And DC fast charging station in China, they are used a CHAdeMO type. And the GBT is mostly used in China. Did I say CHAdeMO in China? CHAdeMO in Japan and then GBT in China. So kilowatt power is different from the individual charging cable, but the above 350 kilowatt charging cable is not standardized yet. So many industry leaders are developing supercharging cables now. But Charin, which has over 150 members in the EV industry, is leading to effort to prepare an international charging standard for high power charging cables. And then, as I told you before, there's some risk and safety measures should be enforced. So worldwide committee-driven standard for megawatt charging is needed to ensure compatibility and convenience and safety, and for worldwide easy spread. Adoption. So next generation aviation charging station and vertiports require special operating systems and network. Real-time weather monitoring is the key. Wind gust, rain, lightning, snowfall, and other micro-weather information should be monitored and reported to the aircraft and the ground operators. And the predictive capability coupled with monitoring can enable dynamic and safer route planning. The next generation aviation requires unmanned air traffic management system and a high-speed communication network. Aviation charging requires, next slide. Aviation charging requires a high-power infrastructure. Electric aircraft charging requires huge amount of power upgrade from the utility companies' grid power, and it will end up at high cost of operating expenses. To reduce the dependency on the grid power and operating cost from the utility company, and to increase resiliency, we can build a solar power, solar panel, and a wind turbine, and install energy storage systems to reduce peak demand charge, and even build a small-sized power plant for continual power supply. As a virtual power plant with a dynamic load balancing platform, you can balance energy consumption for each charging station, trade energy with other networked airports, and contribute excess energy to the local community as a backup power. So this is the model of energy charging hub Vertistop. For ground infrastructure, as Rex explained, there are three kinds of Vertiplaces. Vertihub. Vertihub is kind of a mega airport, LAX or Incheon International Airport. They can be a Vertihub. And the Vertiports, as Rex introduced, the Vertiport has it can be installed in a downtown. It's directly connected to the downtown transportation, has a several vertipad and have an MRO and a hangar. And the Vertistop is just the smallest element of network of Vertiplaces, which can be located at the suburban area, connecting to other Vertistops and the Vertiports. We are designing a charging hub as a Vertistop with the following features. We're gonna have one FATO takeoff and landing spot for one eVTOL and a multi-ground parking spot for ground transportation vehicles charging. And we will serve multimodal vehicles like an e-car, electric van, electric truck, and eVTOL, and electric DC chargers and hydrogen fueling station, and the Vertistop operating software, and a compact terminal with a waiting area, security checkpoint. And we'll have amenity with a coffee shop and a snack bar. And this design illustrates Energy's hydrogen power plant charging hub with renewable energies and a green hydrogen power source. The components are small wind generator, as long as it doesn't interfere with the aircraft operation, and the solar panel, energy storage system, and the real cost R&D's container type power generator, and a smartphone with the heat from the power generator, from the hydrogen power generator. So please watch the video. I can show you the video. So with one FATO, one EV Vertiport pad, and then we're gonna have a ground parking lot with the EV charging station. So with the power sharing, we can dynamic load balancing function. We can utilize the existing electricity capacity for eVTOL and the ground level charging station altogether for the good utilization. Previous slide. The key components for charging stations are electric charging hardware and hydrogen refueling station. Oh, the previous one. And operating event platform. We will provide a DC fast charging station, currently up to 350 kilowatts DC fast charging stations are available, but high power charging station will be developed and available for airplane charging in the future. And we can provide a hydrogen power charging station. And the one more important component is Vertistop operating event platform. It should be 5G network connected and provide location of charging station charging station and the charging status, and the network with the real-time weather monitoring, and the telemetry information, charging management, battery status information, and then it should be over-the-air software updated. So Energy's business model is that we minimize the initial investment, but we will maximize the revenue from the diversified revenue stream. We will minimize our initial investment by utilizing a Vertiport grant program and the charging and refueling stations rebate and incentive program from local government or utility companies, and a tax credit of up to 30% of net project cost, and the food and beverage stores lease payment. And then we will maximize our revenue from diversified revenue streams. The revenue comes from the charging and refueling aircraft and ground vehicle charging station, and the carbon credit trading from based on the kilowatt hour of dispensed kilowatt hour and the hydrogen refueling station, and the aircraft facility usage fee for takeoff and landing from aircraft, and passenger airport usage fee, and then net metering service for excessive energy exporting to the local community or other network airport, and the food and beverage store lease payment, and other income from advertisement, and then etc. So Energy's roadmap of our EV Vertistop is in 2025, we'll do a pilot project. And in 2026 to 2030, we will deploy 10 Vertistops in the United States. And 2031 to 2040, we'll deploy 300 Vertistops in the world. So thank you very much for listening to my presentation. Now, I'd like to introduce Mr. Jiho Choi, the CEO of Realco's R&D USA office. He will present Realco's R&D's green hydrogen power generating system, which I showed in the video. Please welcome him.
Thank you, Ms. Min. I had no idea about how complicated it is to build a Vertiport, and we're just glad that we're not involved in that. We just provide energy for you guys. So good afternoon. Thank you all for participating in the International Vertiport Symposium organized by Korean American Energy Association. My name is Jiho Choi, CEO of Realco's R&D Inc. Our Korea R&D Center is located in Dangjin City in Chungcheong Province. Our R&D Center location is designated as a hydrogen specialized development area by the Korean government. In this research area, we are registered as R&D venture company specializing in hydrogen energy production. Our company is based on green energy technology patents. Our patented technologies are verified through laboratory prototypes in different levels of developmental stages by Korean national universities. We were able to achieve our desired test results by the end of November 2022. So this is the model that you saw. This is where we provide either hydrogen or electricity so that you can move forward with your projects. Let me explain our entire system in a nutshell. Okay. We developed a low power water electrolysis system based on small wind power to generate HHO gas, known as brown gas, and further developed HHO gas burner that generates and burns its own HHO gas through pyrolysis. I'm sure some of you know about pyrolysis. Through this process, we developed an eco-friendly power generation system without producing carbon dioxide or NOx. These are just all the certifications that we have received from Korean government. Okay, the one before. Thank you. Allow me to introduce our key technologies. Our generation system use industry proven and typically used steam turbine generation system, which generally use fossil fuels as its energy source. As you're aware, this popular system has been verified and been used for over 100 years since the Industrial Revolution. The only difference is that our system fires up HHO brown gas as the fuel to generate steams in high heat. This is our green hydrogen cogeneration system. Our key technologies are divided into 3 areas. First technology is water electrolysis system, similar to popular alkaline method. Our key technology that sets apart from the alkaline method is that our system does not use highly expensive metals and KOH solutions in the process. Our water electrolysis system only use water and stacks to produce HHO gas. Our stacks are made by proprietary new graphene compound materials. This is our patented and innovative technology in water electrolysis system. This system is jointly researched and co-developed with the Seoul National University's Future Innovation Research Institute. Through this system, we were able to minimize required electricity down to 24 kilowatts per hour to produce 1 kilogram of hydrogen. In average right now, 1 kilogram of hydrogen is produced for by using 50 kilowatt of hour. This new water electrolysis system will allow us to mass produce HHO gas to reach our future goal of a best case scenario to attain approximately 20 kilowatts per hour from current 24 kilowatts per hour to produce 1 kilogram of hydrogen. In other words, we're improving our efficiency. This is our second patented core technology. It's called HHO burner system that heats anterior heat storage section located inside the boiler to generate additional HHO gas through pyrolysis using recycled steam supply. This technology is co-developed through joint collaboration with the Chungnam National University. So this is complicated, but if you, when you get a chance, when you take a look at it, you will understand. It's a very complicated chemical process, but we were able to reach our results. Next. Okay. Through our first water electrolysis system and additional HHO burner system, we are able to complete the third and final eco-friendly green energy generation system. With our innovative technologies, we can provide green hydrogen and green electricity to all of our partners to eliminate carbon footprints on our planet. Thank you.
Thank you both for great presentations highlighting the importance of some of the energy systems and some of the solutions out there. So I have the pleasure of introducing Ken Reed for your next presentation. Ken has an incredible history of Vertiport and overall aviation planning, simulation expert. He comes from Skyway and brings 25 years of experience across these different areas, and he will be presenting on the Skyway solutions for Vertiports.
I'm honored to be here, and I've been staring at this podium wondering if I can get a water to sit up here, and it can, so that's good. That's exciting. I'm an airport planner. I'm 30 years experience. I specialize in computer simulations of airports and now vertiports. What we're going to talk about today is kind of taking the standards that Rex has talked about developing along with Wolpert and applying them to an actual series of vertiports. We want to know what is the capacity of a vertiport? What's the throughput rate? You can go to the next slide. Because that capacity is what sets the potential revenue for the whole thing. So we have a lot of people who are investing a lot of money in this industry, and we want them to know what the potential is for them to get that money back out. So we're going to talk about industry trends, what we're seeing in the planning and design of these facilities, strategies for local airports. So I'm going to talk about, and you've heard already today, that Vertiport does not cover just one type of vertiport. There are actually different sizes. There are different use cases. We're going to talk not only about those, but what you can do at your airport if you want to direct your development towards one of those vertiport types or use cases. And we're going to talk about how you can integrate vertiports with your existing airport. So I'm going to try to race through this. We're running a little bit behind, so I'm going to skip over some of this stuff, but we're not going to talk about the basics of vertiports. I think you guys have all understood that so far. But basically, it's an on-demand service, unlike what you see at a regular airport. You're going to be able to go to a vertiport, pull up an app on your phone, request a flight, and it's going to show up and you're going to fly to your destination. That's different than what we've seen before. Because I'm an airport planner, I'm always looking 20 years into the future. So I'm looking at fully autonomous vertiports. I'm well aware that at first, these aircraft are going to be piloted. They're going to impact the ATC workload, all of that. But we really want to plan for 20 years in the future, fully autonomous, operating at the highest capacity that they can. And I'm going to talk a little bit about the criteria that we use to get there. And you can go to the next slide, please. That's just a little bit about me. I'm not going to read all of that. 30 years experience. I was also a noise officer at Tampa International Airport. So I'm very sensitive to airport and vertiport noise issues. You can go on to the next. Let me tell you a little bit about Skyway, which is the company that I work for. Skyway is building the transportation management systems for both drones and eVTOL aircraft that are going to operate over our communities. Within that group, I am the senior vertiport integrator, meaning I handle all of the layouts of the vertiports and help the air traffic control system, which is going to be automated, to operate in that vertiport environment. Senior vertiport planner, but I haven't built one yet. So in this case, senior just means old, I guess. You can go to the next slide, air navigation service providers. So this is a woman sitting in what we call one of our navigation chairs. So again, fully autonomous system, but if an error and anything comes up that needs human interaction, then we have somebody waiting in a human in the loop system. But otherwise, it's mostly fully autonomous. Next slide. This just describes what our traffic management system is going to do. It's going to be accepting the flight plans from these aircraft. It's going to be deconflicting anytime that there's a conflict between two aircraft. Generally speaking, it's going to do that by holding the second aircraft before it leaves the ground. We are going to be fully integrated with emergency services, so we're never holding up a police or fire search and rescue operation because somebody ordered Starbucks coffee to be delivered to their home. Next slide, please. These are just some of the partners that we work with every day, including Transoft, which makes the software that I use in order to do computer simulations of vertiports and airports. And Siemens is our electrical partner. So Siemens helps us with a lot of the electrical problems. Next slide, please. So I think I'm going to just very briefly talk about this. We all understand why infrastructure is needed. We are behind the schedule for developing the infrastructure we need so that when these aircraft are certified and ready to operate, we have all of the facilities ready for them. Next slide. This shouldn't be a real question. Vertiports are airports. They're just small airports with very short runways. But other than that, they contain all of the pieces of a regular airport: place to land, place to taxi, place to get refueled or recharged. The three things highlighted on the bottom, though, are different. It's the on-demand service. It's the electric charging of vehicles. I'm not going to talk about that. I think everybody here is aware that these vehicles are electric. Electrification of your airports is the bare minimum that you're going to do in the future for these types of aircraft. And again, it's going to be fully autonomous eventually. Next slide. I'm not going to go through a lot of this terminology. It's all in the standards of that Rex has talked about already. We have a TLOF and we have a FATO, final approach and takeoff area. But of course, just to be confusing in aviation, FATO is also the term used colloquially to mean the entire landing area. So if you hear me talk about FATO, I'm not specifically talking about that band of land around a TLOF. I'm talking about the whole landing area and takeoff area. Parking. If I've discovered anything in the simulations that I've done in the last few years of vertiports, it is that we are grossly underrepresenting the amount of parking, air vehicle parking, that we're going to need at these vertiports. And we're of course going to need parking at the gate area where we load and unload passengers. We all expect that. We're going to have parking for electrical charging. I would recommend you don't do that at the terminal, because if you do at the terminal do your charging, then your terminal building is going to be 3 times as large as it needs to be. So you want to pull that charging off to a separate part of the airport. And once the vehicles are charged, then they're going to go wait in a queue somewhere. I've highlighted 2 items here, waiting and itinerant. Waiting is one of those things that we don't really talk about much. You don't see it written about in the media. Sure, we expect these aircraft to be busy, but they're not going to be so busy that they're never standing still. And so depending on the use case of your vertiport, it will determine how much parking you need, because your aircraft is going to unload passengers, it's going to charge, and then it may or may not have passengers waiting to leave the airport. And if it does not have that, then it's going to sit there, or you're going to have to make it leave. Either of which has a drastic impact on the capacity of that vertiport. Maintenance, taxiways, taxi lanes, everybody gets that. We will need those facilities in the overall system. You might not need them at every vertiport and every vertistop. Next slide. The only thing important here is that when there is an aircraft within that safety area that is on that FATO, it is just landed or it's about to take off, there can only be one. So that also affects the capacity. You can't have another aircraft hovering in over to land on a FATO while another vehicle is already landed on that FATO. So that's one of the assumptions that I needed to do for developing the capacity analysis for these vertiports. Next slide. This is the only exhibit in the Engineering Brief 105 that Rex talks about that actually addresses the issue of putting a vertiport on an existing airport. And it tells you exactly how far away from the runway you need to be based on the size category of that runway. So if you have heavy aircraft coming into your airport and you want to put a vertiport on your airport, you need to be 700 feet away from the center line of that runway. If you're looking at Orlando International, the parallel runways are 4,500 feet apart. If you're looking at Tampa International, they're only 2,500 feet apart. So that is a big deal. How much space do you have to put your vertiport on your airport, which I believe is going to be necessary because airports are going to be the first adopters of this technology. Next slide. Will airports be on the campus with your will vertiports be on the same campus as your airports? I just talked about this. I said, yes, they are. This is how we know that they are. If you go to the AAMRealityIndex.com, which is on the bottom of my slide here, you're going to see that United Airlines has already ordered or pre-ordered 700 of these aircraft. 700 aircraft for one airline alone from 2 makers. Maybe it's coincidence, but United also has 7 hubs in the United States. I'm of the assumption that they're going to take 100 aircraft at a time and put them into one of their hub markets. So don't expect that your vertiports necessarily are going to start with 5 aircraft and grow from there. Some of them are going to start with 100 aircraft on day one, because that's what you need in order to develop this business. If you're starting a cab company, you don't start with 1 cab because you're never going to be reliable. You start with 50 cabs, and the same is going to be true of this type of service. Next slide. For passengers to decide to use the UAM system, this trip must be faster and more convenient than the alternative. Nobody's going to pay more money for a trip that takes the same amount of time. Nobody's going to pay more money for a trip that is way too confusing. So the highest level of service that we as planners and operators of vertiports can provide is to get the passengers onto the aircraft as quickly as possible and get them along their trip as fast as possible. Sure, there are other considerations. Maybe you don't want to fly directly over a neighborhood, so you might go 10 or 15 seconds out of your way to avoid that. But if you're going 5 or 10 minutes out of your way to simply avoid overflying a highway or a community, then you need to reconsider your priorities, because once you pass that line where the trip length duration takes longer than the alternative, you have killed that route and that business. Next slide, please. Will this put extra work on the existing air traffic control system? The answer is yes, certainly at first. These vehicles are going to be piloted. So there's going to be controllers talking to pilots. They're going to be taking off on normal runways. Eventually, however, the system's going to be fully automated. So you would assume no. Next slide, please. But the answer is that yes. Sorry, I think we may have skipped one. Even when they're fully autonomous, and they're operating on an existing airport, the vertiport and the airport have to operate in the same direction. So somewhere there's going to be a controller, whether he's just flipping a switch or calling down to the vertiport operator, there is going to be some coordination. So that will always be true. Now we're going to talk a little bit about use cases, first and last mile delivery of passengers. I've already mentioned United Airlines buying 700 of these aircraft. This is what they're going to use them for. They're going to fly you into a major airport on a existing legacy jet, and then you're going to get off and you want to get on an urban air mobility vehicle to finish your trip. Maybe you're going home, maybe you're going to Disney World, maybe you're going to the Super Bowl, whatever that is. That first and last mile delivery of passengers is a major use case, and I think it's going to be one of the first early adopters because the airlines have invested so much money in this. And from a planning perspective, this is interesting, unique, important, because the flight schedule for the urban air mobility vehicles is going to be very similar to the flight schedule for the airline that is operating that service. It's important to keep that in mind because we need to forecast these operations in the future. If you just, for example, made the assumption that if you took 1% of all of United Airlines origin and destination passengers at O'Hare Airport, for example, you would generate 300 flights per day on these smaller vehicles. It's important to keep that in mind. It's just a relation. Do we think that they're going to jump to 5% immediately? I personally don't. But if I'm planning the system and I'm planning for 20 years out, I might plan for the capability, the capacity for that to be 2.5%, 3%, 4% in 20 years. I wouldn't build it in year one. In year one, I'm going to build 1 or 2 FATOs and just enough parking to get by for the number of aircraft that the airline or some other operator is going to bring in. But I want to make sure that I have that capability and I'm scalable so that I can do that. Next slide. Commuter travel. Just as you would expect, passengers are going to leave their neighborhoods and fly downtown to work during the day, and they're going to fly back out at night. This is, again, a different use case, a popular new use case, one that is easy to understand, but it has a drastic effect on the planning of your vertiport. So if your vertiport is in downtown somewhere, you don't want to put it on a rooftop of a garage because you're going to have a lot of vehicles are going to come in and they're going to unload their passengers. And it's just like Uber or a taxi cab. You're going to see them hanging around hoping that they can catch a passenger on their way out. And if they don't, you either have to provide parking for them or you've got to incentivize them to get off your vertiport. And if they leave that vertiport because you've set the hourly parking rate so high, for example, then they're going to use your FATO twice. And by doing that, there goes your capacity for your vertiport again, because now you've doubled the amount of time they're going to spend on the FATO. You have not increase passenger capacity because half of your flights are going to be empty. You might double your landing fees because you're going to make that aircraft come back. But I don't think that that's really worth it. And it doesn't help your level of service. The commuter travel, again, the flight pattern is going to look just like commuters. It's just going to be everybody going downtown in the morning and leaving in the afternoon. Next slide, please. The random or point-to-point use case, hard to plan for. It's not a big demand type. It's just going to be my wife is going to take the Vertiport that's in my neighborhood and she's going to fly to the mall or go to one dinner somewhere on the other side of town. You can't predict it. You just put in a bunch of flights that are random between those Vertiports and do the best you can. Next slide. Itinerant. You don't hear a lot of talk about itinerant operations at Vertiports. These vehicles are not just going to be efficient to operate by the airlines. They're going to be efficient compared to other general aviation aircraft. You're going to see people start to buy these electric vehicles instead of buying the Cessna 310, the Cessna 172, et cetera. It's going to eat into your business, your fleet mix at your airport as they replace the older types of vehicles with these newer electric vehicles. So you want to make sure that you're able to store and maintain those aircraft. And also it gives you a very different type of operation than what you might have had before. These vehicles might do more trips more frequently, shorter durations, and you need to plan for that. And plan for parking. If your Vertiport is near, for example, the Super Bowl, and when I was the noise officer at Tampa International, I want to say in 2004 or so, they had the Super Bowl at Tampa. Runway 927, the east-west runway was closed. It was packed with corporate jets. So imagine that if Tampa hosts the Super Bowl, it's going to be packed with corporate jets, and they're going to get off those corporate jets, and then they're going to fly their eVTOLs over to the stadium. That might be an exaggeration because it's literally across the street from the airport, but I think you get the idea. Next slide, please. I'm going to skip over this slide. Go to the next slide for me. This is a new way of thinking. I don't know if you can see this. In the simulations that I have done, we laid out Vertiports with FATOs left to right. I have an arrival FATO and a departure FATO, so I end up with this grid of FATOs where they're arriving on the bottom and departing on the top. And the aircraft can, it's scalable, so you can start with only 2 FATOs and grow up to 5 or 10 or however many you need. But the only problem with it is if you had a direct crosswind, your Vertiport might be closed. Now, we're not even sure what the crosswind components are of these aircraft yet. But once we find out, you don't want your Vertiport to be closed because you have a crosswind. But by putting them in a circular fashion, and I don't know how well you can see that graphic, I now have 3 arrival FATOs on the bottom of my circle and 3 departure FATOs on the top of my circle. If the wind shifts 90 degrees, I'm not closed. Now I just have 3 arrival FATOs on the right side of my exhibit and 3 departure FATOs on the left side. I can't do this with an airport because I can't rotate a runway. But with a Vertiport, I can lay them out in a circular fashion, we believe, and operate that Vertiport in whatever the wind direction is. Next slide. And this is what this looks like when you lay out a Vertiport with a terminal in the center to minimize the taxi times. Gates are wide at the airfield side because I lay out a Vertiport so that the aircraft can come in and turn. Halfway through the turn, he unloads and loads up his passengers. If you simply pull up to a terminal, face up to the terminal, then you got to back out or have the aircraft tugged, and we're trying to avoid all of that manpower. So wide on the air side, getting very narrow to the land side because the gate doesn't have to be very large. The aircraft only holds 4 people. So even if the gate held the next 3 flights worth of people, we're still talking fewer than 20 people. And I think that's it. Next slide. Oh, I'm going to skip through. Let's go. I'm going to skip through a lot of these. Let's skip through until just go. I'll show you when to stop. Right here. This is the Vertistop. We talked about this earlier. This is the smallest possible vertiport. But how big is it? Well, I'm showing it at 3.1 acres. If you put a fence line around the entire what was the heliport protection zone, which is not in the engineering brief now, but maybe. But it's basically an area large enough so that if a kid was sitting at the end of that fence line, he'd have to throw a basketball 50 feet in the air in order to get above the aircraft. And next slide. And this is what it looks like when you put it on top of a football field. So when you see a lot of graphics, NASA exhibits even, where they're showing aircraft taking off tops of buildings and tops of parking garages, keep in mind that this is still a pretty large space. If you include the safety area around the FATO, that's 150 feet across. It's about 3 football fields in length to include that. Let's run through to the next one and keep going. This is just showing that I need more gates and keep going. One more. If I include the airspace surfaces, that's what that looks like. This is now 21 acres. Keep going. Almost 1 million square feet. This is only 2 FATOs, 1 arrival, 1 departure. Keep going. Now let's go to 4 FATOs, 2 arrivals, 2 departures. Now I've introduced the terminal building. Everything smaller than this, I didn't necessarily need the terminal building. Now I do, because I've got 7 passenger gates alone. And next slide. And I had 15 charging spots, 8 queuing, 44 acres for a 4 FATO vertiport. Next one, last one, we talked about. Go ahead and skip through these couple of slides. We can move surfaces. And next one, we're going to go to the biggest possible, what we talked about earlier as a Verta hub. And one more. Here's that centrally located terminal, 7 FATOs around it, 4 for arrivals, 3 for departures, because we think it's going to take longer to land than it is to take off. And one more, I think we'll get to the total acreage. We're up to 87 acres. So keep that in mind when you're planning these vertiports at your airports. One more, I think will finish us off. Keep going through these. And one more. One more. Finally, a Vertipark. Vertipark, special type of vertiport, not meant for passengers at all. This is a vertiport meant just for the aircraft. If you Google the word vertiport, sorry, and you look at the images, artist renderings of vertiports, you never see enough parking. You certainly never see 200 parking spots, but that's what you're going to be bringing into your community. And so if your vertiports aren't big enough to hold the parking overnight in storage, then by putting in a Vertipark in your community, you can have them all charge in one location overnight. The charging will be less expensive because you're delivering the electricity in bulk. You're also doing it at night. And ideally, if your airport has enough space for solar panels, you can minimize that cost as well. And as you can see, it's a pretty large space relative to the FATOs, which are each 300 feet apart. Next one. And that's it. Does anybody have any questions? I hope I was able to catch up on our time a little bit.
Questions to the end here. So thank you so much, Ken, for that great presentation. It's really informative. And I think we all gather some of the complexity of what happens when you have to introduce multiple FATO into one of these facilities. Thank you so much, Ken. We're going to go into our last presentation. I'm pleased to introduce Tae-Ho Kim. He's the founder and CEO of Port One and Vertiports. He's going to be talking about product that he specializes in, basically takeoff and landing infrastructure, with the intent to launch their infrastructure in Korea in the 2024-2025 timeframe. So I will pass it over to our digital presenter, and thank you, Tae-Ho, for spending your time with us this morning.
Hello, everyone. Can you hear me?
We can hear you.
Hello, everyone. My name is Tae-ho Kim, CEO of Port One. Port One is the first Vertiport startup company in Korea. I'm grateful for the opportunity to speak at the International Vertiport Symposium. Today, I'd like to discuss three main topics. The first is issues of UAM commercialization in Korea. And the second is Vertiport. And the third is Port One. Part one, issues of UAM commercialization in Korea. There are many issues related to UAM commercialization. But today, I will talk about two major issues. The first, there are many tall buildings in the city of Korea. So if we start UAM commercial service in the city, safety cannot be guaranteed. And it's difficult to reach a social acceptance. Because of this, Vertiport is also in a situation where it has to move to low-density area, not to high-density area. This is a problem common to many countries in the early stage of UAM commercialization. And the second issue, if Vertiport moves to low-density areas, the decreasing attractiveness of the Vertiport business, revenue may not be secured, making it difficult to provide continuous UAM and Vertiport service. As mentioned, if UAM commercialization starts in a low-density area due to safety and social acceptance, it may be difficult for the Vertiport business to maintain a sustainable business. To solve this problem, we need to find alternative locations with sufficient demand. Maybe tourist destinations could be a new alternative. For Vertiport operators, tourist destinations have a good conditions to form a nationwide Vertiport network. Local governments interested in UAM industry can lay the foundation for the UAM industry by building Vertiport in tourist destinations. And tourists can be the best customers in the early stage of UAM commercialization. Building Vertiport in tourist destinations is a win-win for Vertiport operators, local government, and tourists. However, the currently discussed concept of Vertiport cannot meet the needs of tourists. Tourists in tourist destinations simply want a quick transportation. A fixed corridor should be used by 2030 in Korea. Is it possible to do sightseeing like Vada view in a fixed corridor? The land side of many of the currently proposed Vertiport prototypes mainly considers only facilities that provide temporary convenience for movement. That's a problem. Next slide. In this situation, Vertiport may be an alternative. Vertiport is a Vertiport built-in tourist destination. Let's see how Vertiport is different from other Vertiports. Vertiport has a difference in Vertiport operation. Tourists demand a moderate speed aircraft that can enjoy sightseeing as well as moving quickly. In addition, Vertiport operates needs an aircraft that can carry many customers. Therefore, Vertiport must be a space where eVTOL and eSTOL are operated together. Next, Vertiport has a difference in corridor and airspace. According to the KAEA plan, a dynamic corridor network will be applied after 2035. However, it is necessary to consider a dynamic corridor network within tourist destinations where Vertiport is located. Vertiport should play a role in airspace control of the entire tourist destination, not just around the Vertiport. Vertiport has a difference in facilities. Vertiport should have a wide range of amenities and services that are geared toward the needs and preference of tourists, such as accommodation, dining options, entertainment, and cultural activities. Vertiport operates on a revenue model that generates more revenue from non-air activities. That's important. In order to successfully operate Vertiport, there needs to be extensive discussion regarding the operation of the Vertiport, the facilities within, as well as the corridor and airspace. It's important to recognize that Vertiport is not just a Vertiport situated within a tourist destination. It represents a new form of tourism that combines a novel mode of transportation with a modern tourist destination. Discussion on Vertiport has already taken place in Korean National Assembly in last November, with Volocopter Korea, Korea Institute of Aviation Safety Technology, and Port One taking part, and mentioned three major issues. First, including tourist destinations in the special exemption for UAM pilot operation areas. Second, adding Vertiport as a new business operation under the Tourism Promotion Act. The third, dynamic corridor network operation permit granted for certain designated areas of tourist destinations. For part one, part two, I talked about the issue of UAM commercialization in Korea and the reason Vertiport came out, and the difference between Vertiport and general Vertiport. Also talked about Vertiport discussion in Korean National Assembly. In part three, let me tell you about Port One. Port One started in 2021 and signed the first Vertiport site contract in Korea in February 2022, and established a branch office in London in August last year, and promote Vertiport-related business in Busan, Sejong, and Incheon. Port One received investment of 10 billion won value in last year, and is working hard to secure SI investment and partnership this year. Next. Port One is focusing on technical content related to Vertiport operation and demonstration, subdividing it into 8 categories: Vertiport system integration, air traffic management system, MRO machinery and equipment, weather observation system, communication system, precision landing guidance system, Vertiport operation demonstration and development. And we are developing information and technology for each of the approximately 200 subcategories. Now, Port One plans to build 15 to 20 Vertiports across the country by 2028. These Vertiports would include both Vertihub and Vertiport. Apart from this, we are discussing the Vertiport project with the local government from the perspective of creating a future industry. Next. We also aim to be one of the top 10 Vertiport companies globally by 2030. To do so, we will work on making a standard Vertiport in 2025, along with securing the operating area of Vertiport in 2023. And in 2027, we plan to expand overseas. Next slide. To achieve this goal, we have a team of 3 C-level directors and the external advisory board consisting of 8 members with diverse expertise and perspectives. Although Photon is currently a small Vertiport startup in Korea, but we have a big dream of Skyverse and being the first company in the world to achieve this. Skyverse means a world where everything that is done on land is also done in the sky. If we want to know about the Skyverse, you can buy the book, The Skyverse Era, created by UAM. Scheduled to be published in mid-July in Korea. Today's speech was my first English speech in the early morning, so it may have been difficult for many people to understand properly. If you have any questions about today's speech or Photon and anything, please contact us by email. Thanks for your attention.
Thank you so much, Taeho. So this was a great session. We heard a lot about aviation following suit in the sort of march towards zero emissions future, energy really being a critical underpinning methodology of how we're going to get to that future of zero emissions aviation, the ways that electrification can prove sort of a public-private model for scaling, and the need for sort of scaling, planning for convenience, and making sure these are easy journeys. So I think we have a couple of minutes. We want to take a question from the audience. Happy to do so. Otherwise, I'm sure our presenters are available after the session to answer any questions that you might have. But anyone that comes to mind wants to chime in right now? Okay. Otherwise, we will power through. I think we have our folks on the line who are joining us from Korea, so I want to respect their time. I know it's morning for them. So our third session is really going to be focused on the role of vertiports in airport planning. So we've got 2 really great speakers. The first that I'm really pleased to introduce is Min-Chul Chung. They're the UAM team leader at Korea Airport Corporation. And they'll be talking about ground infrastructure of urban air mobility. So please give a warm welcome. And do we have you on the line? Min-Chul Chung, do we have you on the line? Just 1 second, we have a little swap out of speakers, so it's a minute while we get the digital worked out. So we're going to go ahead and jump forward while we try and get her back. So really pleased to introduce Jeon Kim, the manager of future transportation at Incheon International Airport Corporation. She's going to be talking about a lot of really exciting activities that have been happening at Incheon Airport and UAM. And also, please welcome Jeon Kim, and I'll pass it over to you. Jeon, do we have you on the line?
Hello, can you hear me?
Yes. Thank you so much. I'll hand the presentation over to you.
Okay, thank you. Okay, Good afternoon, ladies and gentlemen. I'm Jiyeon Kim, the manager of the Future Transportation Team at Incheon International Airport in South Korea. Today, I'll present on the current and future of Incheon Airport urban air mobility. Next page, please. Let's begin with an overview of why Incheon Airport is committed to working on UAM. Next page. As many of you already know, Incheon International Airport serves as the gateway to South Korea and is renowned for its outstanding features and advantages. Next page. However, despite our efforts, we face a geographical limitation. The biggest challenge for Incheon Airport is accessibility. The distance between the airport and Seoul results in long travel times despite existing transportation systems. The physical distance between Incheon Airport and Seoul is quite significant compared to other major airports in East Asia, even when compared to Gimpo Airport in our country. Next page, please. To address this challenge, we see urban air mobility, the UAM, and eVTOLs as potential solutions. The UAM airport shuttle can significantly reduce travel time and improve accessibility while relieving ground traffic congestion. Next page. Now, let's move on to the current stage of Incheon Airport's UAM initiatives. Next. In June 2020, the Korean government announced the UAM roadmap aiming to commercialize UAM in South Korea by 2025. Next. As a member of UAM Team Korea, Incheon Airport collaborates with the government, industry, and academia to develop policies and achieve successful national commercialization. Next. Can you please turn the page to next? Okay, this is Incheon Airport Vision 2030 Plus, and this outlines our long-term goals and strategies. The UAM airport shuttle falls under the Connect the Future category. Next. The UAM airport shuttle brings various benefits, supporting the development of the domestic UAM industry and enhancing accessibility and passenger experience at the airport. Next. The long-term roadmap of Incheon Airport includes 3 stages. The first is construction of vertiports, and the next is commercialization of the UAM airport shuttle, and for the final development of the vertihubs. Next. Let me provide a brief explanation of Incheon Airport's vertiport infrastructure and UTM plans. Regarding vertiport infrastructure, the facilities will be expanded over time, progressing from vertistops to vertiports and ultimately to vertihubs. Initially, the plan is to start with vertistops located on the current helipads or airport outskirts, ensuring safety and minimal interference with conventional aircraft. As time progresses, the aim is to construct advanced facilities like vertiports and vertihubs near the passenger terminals, enhancing convenience for passengers. Next page. Incheon Airport is involved in the national UAM R&D project and is currently focused on 2 specific projects. One is developing reliability verification technology for low-density UAM traffic management, and the other is creating a virtual UAM operational environment. These projects' timeline includes progressing towards digital twin migration, advanced flow management, safety control, and the integration of UTM and ATM, ultimately aiming to provide services for autonomous UAM operations with advanced integration and various AAM applications. Next page. Okay, establishing strong partnerships with industry leaders is crucial in the developing phase of the UAM industry, as standards and regulations may vary among regions. Incheon Airport recognizes the importance of driving its own standards in the industry and has established partnerships with private sector companies. The consortium includes Hyundai Motor Company, Hyundai Engineering and Construction, KT, and Korean Air. The goal of this consortium is to take the lead in vitalizing the UAM ecosystem, and we already developed a concept of operations that leads to detailed design and requirements for the UAM industry with strong consensus. Next page. Incheon Airport also participates in the KUAM Grand Challenge, a national demonstration program to pave the way for commercial eVTOL operations. Next. And these are the efforts to increase public acceptance, include hosting annual KUAM Confex with Incheon Metropolitan City and conducting flight test demos with UAM companies like Volocopters. Next page. So far, we have explored what Incheon Airport is doing to facilitate the successful adoption of UAM. Moving forward, I'll provide a brief overview of the future of Incheon Airport's UAM initiatives. Next page. This is the key point of my presentation. Unfortunately, there is currently an obstacle preventing Incheon Airport from realizing UAM operations within the airport area. The layout of Incheon Airport includes 4 runways arranged in a strictly parallel configuration with passenger terminals 1 and 2 located between these runways. While it would be ideal to locate a vertiport near the passenger terminals for convenience, the present technology does not allow eVTOLs to cross the runways safely. If an eVTOL were to approach from the east, where the capital city Seoul is located, it would pose an extreme risk to both conventional aircraft and eVTOLs. Consequently, to reach the passenger terminals, eVTOLs would need to take a detour over the ocean and carefully navigate through a narrow path between the runways. While this detour allows for sufficient separation between aircraft and eVTOLs over the ocean, it results in longer flight times and a riskier path due to the narrow available airspace. As a result, the location of the vertiport needs to be carefully selected, prioritizing safety as a foremost value in the aviation industry. Next page, please. To provide a more detailed comparison, let's explore the 2 options in more depth. Case 1. In this scenario, the vertiport would be located on the east side of the runways, eliminating the need for eVTOLs to cross the runways or detour over the ocean. The primary advantage of this option is that it minimizes interference between conventional aircraft and eVTOLs. Additionally, air traffic control would be more convenient since the routes of eVTOLs and aircraft would not overlap. However, the main drawback is that this location is far from the passenger terminals, which could potentially cause inconvenience for passengers. In case 2, alternately, placing the vertiport near the passenger terminals in case 2 would significantly reduce the time and energy required for passengers to reach the vertiport. This option prioritizes passenger convenience. However, it poses safety concerns regarding interference risks between eVTOLs and conventional aircraft. Additionally, air traffic control would be more challenging and riskier, requiring various other solutions to effectively separate eVTOLs from conventional aircraft. Both options have pros and cons, leading to a dilemma for us in decision-making. Next page, please. Okay, moving on to the next page. It's important to note that the remaining pages related to Incheon Airport's vertiport location and facility plan are potential plans that are not yet finalized, decided, or official. These are just brainstorming ideas under consideration. Therefore, I kindly request that you treat this information as a confidential brainstorming concept and refrain from sharing it as an official release. And considering the early stage of the industry starting from 2025, the focus is on minimizing safety risks as discussed earlier. Given the need for careful consideration of safety, the initial locations being considered are situated on the east side of the runways, near the cargo terminals and Lodges Park. These locations provide a balance between safety considerations and operational efficiency at this early stage. Next page. The Vertiport facility in the early stage would consist of takeoff and landing sites, small passenger facilities, and monitoring system. Next page. In the future, once the UAM industry matures and advanced technology has addressed safety concerns, the goal is to have vertiports located at the passenger terminals, enhancing convenience for passengers. This concept design presents the integration of a vertiport within the fully constructed passenger terminal 2 of Incheon Airport. Next page. The concept design for the Terminal 2 Vertiport proposes locating the facility above the short-term parking lot located directly in front of the terminal. However, it is crucial to emphasize that safety and technological challenges must be resolved first. Next page. This is a potential facility size, a layout with several photos and aprons. Next page. While final decisions on vertiport location and infrastructure are not yet determined, Incheon Airport is preparing for UAM operations, including implementing a helicopter airport shuttle service. Next page. Next page, please. Given the current challenges in UAM operations, a viable alternative is to utilize helicopters. By starting with VTOL aircraft, such as helicopters, and transitioning to eVTOLs once they are commercially available, the groundwork for UAM services can be established. Next page, please. Collaborating with a company named Moviation, Incheon Airport is working together to establish UAM services and infrastructure for existing VTOL aircraft. Next page. This is the full service procedure. Next. The shuttle service will begin at the existing Incheon Airport helipad, providing passenger facilities for convenience. Next. Initially, the shuttle service will focus on transportation from Seoul to Incheon Airport, with plans to extend to nearby tourist destinations. Next page. The construction of the passenger facility is underway, and a partial service launch is anticipated in the second half of the year. Next page. Okay, this concludes the presentation. Thank you for your attention.
Thank you so much. Incredible presentation. I've had the privilege of being able to spend some time at Incheon. This is very exciting. So we were able to get our other speaker. I'd like to introduce Minchul Chung, the UAM team leader at Korean Airport Corporation, particularly focused on ground-based infrastructure for urban air mobility. So Minchul, do we have you on the line? And can I go ahead and pass it over to you?
Yes, hello, can you hear me?
Yep, we hear you loud and clear. Thank you.
Thank you. I'm sorry about the technical problems previously. I actually joined it from the beginning phase, but I realized that I participated as participants, not speakers, so I reconnect to this room. Sorry. And actually, my name is Hyung-gyu, and I'm deputy director of the UAM office in Korea Airport Corporation, and Minchul Chung is sitting next to me because he had to go an urgent meeting soon. So I will do a presentation for this time. So next. So my presentation consists of two parts. First is our UAM business plan, and second is our Vertiport plan. Next. So let's first let me talk about and introduce about our UAM business plan. Next. So let me introduce about KAC. This is the Chinese characteristic, and this means that this is main house. So the KAC is we can introduce KAC as the main house of Korean aviations. We have 43 years experience, and we operate all airports except Incheon airports in South Korea. Next. And we 100% state-owned, and we have, like I said, 43 years experience, and we won ATRS Operational Excellency Awards. And also we operate civil aviation training center in South Korea. And we handled 86 million passengers before coronavirus. Next. So this is the airports that we are now operating. We are operating 14 airports, and we are considering to construct and operate 8 new airports in the future. Next. And also we are ANSP in South Korea. So we are now operating ATM system, including air traffic control system, communication system, air traffic flow management system with the air route traffic facility centers. We are now operating Incheon Area Control Center, Daegu Area Control Center, and 10 BOTAC facilities. Next. I think everyone is expert in the UAM field, so I will skip in this slide. This is just for the explanation of the UAM. Next. So based on our role, we are considering to be a Vertiport operator and UAM traffic management, and also we are gonna do a UAM traffic management. So for the Vertiports, we're gonna construct and operate the Vertiports. And since we have 14 airports in South Korea, we're gonna construct the Vertiports based on our airports so that we can construct the regional air mobility ecosystems, and we're gonna apply to the new airports. And for UAM traffic management, we're gonna construct a UATM system and operation system. And in the end, we're going to combine entire airspace solutions. So we're going to combine drone system and UAM system and ATM system. Next. So like everybody knows, the UAM arise to solve the urbanization and traffic problems inside the city. But can UAM solve the urbanization and traffic health? Next. And also, is it possible to realize the movie of the Fifth Elements? Because every media introduced UAM as air taxi and fully automated flying cars. Every public think that the UAM will be operate like this. Next. But there are hundreds of hurdles for our UAM, for a full automated UAM. We have to solve the we have to consider economy and selection factors, and also we have to consider all of the legal and regulations, and etc. And also for infrastructures, I'll talk about the hurdle for the infrastructure for the next slide. Next. So let's think about this. UAM is not fully automated flying car, but it can operate the electronic fleet of aircraft like electronic helicopters. It will be possible in the early future. Next. So for the initial phase, the Korea Airports Corporation, we prepare UAM for a regional air mobility. UAM will be the effective way for the regional transportation, because since the transportation system is very well developed in the Seoul metropolitan city area, and in the initial phase, the ticket price will be high than comparatively than the other transportation modes. The regional transportation will be the most effective way to apply in South Korea. Next. And also we think the airport-based RAM service can be the complementary airports access transportations. And also it can create new point-to-point tourism demands in the future. So like I introduced in the previous slide, we are now designing and preparing for the new airports. We're going to construct all of the vertiports to the all new airports. Next. Let me skip this slide next. I think that the image is not working in this slide, but I can explain. So in the initial phase, we think the touring for the tourism purpose will be the most effective way to commercialize the UAM. So we focused on the Jeju Island and Southern Coast Marine Tourism Belt in the initial phase. Next. This video is the concept of the tourism UAM in the Jeju Island, but since we cannot play this video, so you can find this video in the KAEA Airport Corporation YouTube channel. So let me skip in this slide next. And we make the UAM ecosystem with our partners. So for our business, we are cooperating with SK Telecom and Joby Aviation and Hanwha System and Overware. And also 3 public institutes are supporting us with the traffic and demand research and geographical information and weather detection and forecast system. Next. So let me introduce about our Vertiport plan. Next. So we think that the 3 components is the key for the UAM service. First is eVTOL, second is Vertiport, and third is UAM traffic management. Next. And you know, the Vertiport, which is the ground infrastructures for the UAM, is the linchpin for the urban air mobility. Next. And actually, we are now preparing the Vertiport operation in South Korea. We found out that there is many hurdles to construct and operate the Vertiport. Like we have to select the land and location, and also we have to consider the surrounding areas obstacles, and also we have to supply a large amount of charging facilities, and also we have to consider the urban planning. So we have to cooperate with local governments. And also we have to consider the whether this Vertiports can infringe the property rights, because when we build the Vertiports, there will be obstacle clearance surface nearby Vertiports. Then the buildings next to the Vertiports cannot build high buildings so that they can like sue to the Vertiport operators. So we think this is the most important considering factors for considering and operate the Vertiport. And next. And Vertiports have to converge all transportation so that the Vertiport have to consider the connections between the other transportation, including the futures one. Next. And also the mouse service is critical for the UAM operations. Like everybody know about this slide, so let me skip this slide also. Next. And this Vertiports as a mass stations will be the core in the future traffic infrastructure in the city. So we are also considering for the new hometown in South Korea, not only the current urban core area. Next. And we think the hub, similar with the hub spoke model in the legacy aviation, will be also affected for the UAM industry, because it is really hard to secure land in the urban core area, but we need a large land to park for the overnights of eVTOL and for our MRO and for of a charging station, so that we think we have to centralize all of the functions to the Vertihub, and then the potent stop can let its burden for the functions, so that they can construct depending on its size and land size and demand and etc. Next. This video also uploaded in our YouTube channel. So please find out this video in our Korea Airport Cooperation YouTube channel. Next. So we also set the level of the vertiports. The biggest one is hub, and mid-side is put, and small this side is stop. Next. And I'm really glad to introduce our project. And we are now preparing for the Gimpo Birdie Hub in front of the Gimpo Airport's domestic terminal. Next. And this will be the mobility hub in this whole. So it will combine all the transportation modes, including 5 subway lines and SBRT and taxis and express bus, etc. Next. It consists of 3 blocks. So block A will be the mobility hub, like I explained in the last slide. And it also includes block B and C. And block B will be the aviation clusters, and plus C will be the innovative mobility cluster. And so that we can combine all of the stakeholders so that they can make synergy. Next. So let's focus on the block A, which is the mobility hub. So we will use the rooftop for the Vertiports, Birdie Hub, and also from the underground, it will combine the SBRT and 5 subway line. And also we will have, this building will have the cultural park and commercial complex and also e-charging zone. Next. And this is not just a picture. We are now undergoing the preliminary government feasibility study. And at last, next month, we will get the result from the government. Next. And this video clip is also about our Birdie Hub projects, and also you can find out in our YouTube channel. Next. Let me explain about how we think to select the Vertiport and stop site. So for the page 1, we need to determine the UAM Vertiport quantity in the city. And we have, for this, we have to consider the demand, UAM demand and government policy. And next, we need to, sorry, the previous slide. And next, page 2, we need to select the UAM service area. And in this space, we have to consider conversion demand and also other factors like geographicals and demographical things. And also we need to consider public purpose and also complementary means of transportation and also induced demand. And the last page 3, we can select Vertiport's location in the UAM service area. And in this space, we have to consider economic factors, technical factors, and social factors. Next. So so for the initial page, the Vertiport and stop, we start from the public land, because it is really easy to secure land by negotiating with the local government. So we are now cooperating with our local government, but in the end, it can expand to the various locations like intersection, rooftop, and urban stream, and highway, and etc. Can I stop my presentation here, because next is a description of the UAM system. So thank you for listening my presentation. And thank you for your listening.
Thank you so much for the great presentation. Thank you to all the speakers. I know we powered through a lot of content today and in compressed timelines, but we covered a lot, and hopefully the audience was able to take a lot away from today, starting with all that Vertiport orientation, regulation, all the way to what does this actually look like when you start putting it in airport environments and off airport environments. So with that, I will pass it back over to Mr. Sam Kim to close us out. If we have any questions, like I said, I think the speakers are around, and I'm sure you can track down their email. So please feel free to reach out to them. And otherwise, thank you so much for hosting us today. This was excellent.
Thank you. It has been about 3 hours. Thanks for your attending this symposium. We heard a lot of challenges about developing Vertiport, but also we heard a lot of solutions for the problems, to develop a Vertiport. What I see today is I think the Vertiport will be a reality sooner or later. And I saw a lot of energy and a lot of enthusiasm, and also a lot of interest in the investment in this new future of air mobility. So I think the time is coming, and we're gonna see a lot of some new development probably very soon, probably this year or next year. I'd like to have a couple of some reminders. Couple of reminders. Number one, all the PowerPoint slide, present slide will be available on our website. Our website is KAEnergy.org. And also another announcement is we have a VIP dinner reception after this event. So those who are invited for the dinner reception, please join the dinner reception. If you don't know the location, please see me. I will let you know it. Thank you. Thank you so much. Have a good night. Good evening. Bye.